Every minute of every day, we are consuming energy. It is what makes the world go round. Right now, we rely primarily on fossil fuels to meet our energy needs. It's a matter of balance between our demand for energy and our supply. If our demand for energy goes up, we pump more fossil fuels. But what if we don't want to rely on fossil fuels to meet our energy demand? Can renewable energies balance our consumption? How big is our energy demand? And how much energy can renewables actually supply? When we talk about quantities of energy, we talk about kilowatt hours. One 40-watt light bulb running continuously all day long consumes 1 kilowatt hour. The average American uses around 240 kilowatt hours worth of energy every day, which is equivalent to having 240 light bulbs running continuously. Let's look at the United States as a whole. Our energy demand has been steadily increasing over the past 50 years. Currently, the United States consumes 70 billion kilowatt hours of energy every day. This is enough energy to have 30 billion light bulbs running continuously, and is the same amount of energy that is released in a volcanic eruption. But where is this demand for energy coming from? What do we use this 240 kilowatt hours per day of energy for? Let's start with our car. Between getting to and from work, running errands, and going on outings, we drive around 30 miles per day. If our car gets us 22 miles per gallon, that costs us 50 kilowatt hours. Even though most of us don't fly a plane on a regular basis, taking just one international trip a year, or several smaller trips, costs a lot of energy. Averaging out annual air travel comes to about 30 kilowatt hours per day. Controlling the temperature of our environment consumes energy. Heating and cooling our homes and workplaces uses 25 kilowatt hours per day. In addition, we use energy to cook our food, as well as heat water for showers, washing dishes, and doing laundry. This adds another 12 kilowatt hours per day, bringing the daily total energy used to alter the temperature of our environment to 37 kilowatt hours. Every time we turn on a light switch, we're using energy. Illuminating our homes and workplaces requires about 4 kilowatt hours per person per day. Running the gadgets and electronics that keep us occupied also uses energy. From the computer to the cell phone, TV to vacuum cleaner, digital clock to printer, if it plugs in, it uses energy. All of these devices combined use around 5 kilowatt hours of energy per day. Even just fueling our bodies takes energy. Eating a 2,500 calorie diet requires a minimum of 3 kilowatt hours per day if we were to live on a vegan diet. Consuming food from animals, be it meat, eggs, or dairy, costs additional energy, as the animal needs to be fed and reared. In addition, fertilizing plants and powering farm equipment requires energy as well, bringing our total energy for food to 17 kilowatt hours per day. We fill our lives with stuff, and making all of that stuff takes energy. From the small things like aluminum soda cans and newspapers, to the big things like houses and cars. Gathering the materials and assembling the goods we buy and use takes energy. About 70 kilowatt hours per day worth of energy. On top of that, we use energy to transport all of this stuff. Planes, trains, boats, and trucks move all of the goods we buy from the factories to the stores, adding another 21 kilowatt hours of consumption per day. The public services the government provides also require energy. Services like repairing and building roads and military defense add another 6 kilowatt hours per American per day to our energy consumption. All in all, this comes to 240 kilowatt hours per day. So what if we want to meet our energy demand with renewable resources alone? Is it possible? Can we retain our standard of living while eliminating our dependence on fossil fuels? Does it all balance out? Let's look at how much energy we can get from each renewable resource. Wind energy has the potential to provide a significant amount of power to the US. Developing wind farms on land that is not urbanized, forested, farmed, or environmentally protected could contribute 42 kilowatt hours per American per day. Achieving this level of wind production would require a 200-fold increase in current wind capacity, with wind farms covering an area roughly the size of California. If we also include the energy offshore wind farms could provide, an additional 5 kilowatt hours of energy could be achieved, bringing the total energy from wind to 47 kilowatt hours. Geothermal energy captures the natural warmth of the earth to produce electricity. Tapping this renewable resource could provide an additional 8 kilowatt hours of energy. Harvesting the energy of moving water through hydroelectric dams is a well-proven source of renewable energy. If the United States doubles its current hydroelectric capacity, this would add an additional 6 kilowatt hours of energy per day. The oceans also provide a source of renewable energy through tides and waves. However, over the United States as a whole, it will only contribute a couple tenths of a kilowatt hour of energy per person per day. If we implemented each of these renewable energy technologies to their fullest, they would add up to 62 kilowatt hours per day, just over a quarter of our energy demand. However, we have yet to look at the energy solar could provide. The deserts in America's Southwest have a huge potential for solar development. Covering 54,000 square miles of desert with solar farms would provide enough energy to meet our demand. This level of solar farm development would fill a square of 230 by 230 miles, or about 47% of Arizona. If we wanted to use only solar to meet our entire energy demand, we would just need to increase the size of the square. If instead we covered 63% of Arizona with solar panels, solar energy would meet our entire energy demand for the United States. Theoretically, it is possible to meet our energy demands with renewable energy, but how realistic is it? What if we don't want windmills in our backyard? And can we really cover an area half the size of Arizona with solar panels? If this doesn't seem feasible, then we are left with balancing the scales by cutting our demand or turning to nuclear energy. Our 240 kilowatt hours per day of demand is about twice the energy consumption of the average European, and 4 times the global average energy consumption. With conscious effort, we can reduce our energy usage. Limiting the amount we travel, as well as turning down the thermostat in winter and turning it up in summer, can make big reductions in our energy demand. We need to pay attention to where we use energy and count our consumption. While obstacles still remain for renewable energies, such as cost and storage issues, renewable resources have the potential to meet our energy demand. Working to reduce our energy use, however, will help significantly reduce the barriers to renewable energy. So yes, we can reduce our reliance on fossil fuels, but it will require a combined effort of improved efficiency and new technologies. We can get the scales of supply and demand to balance out. It is now just a question of whether we will.